So in our next section, we will discuss some of new trends and new technologies that could have been in the market for many years till now, but it is still in its early stage, such as cloud computing, such as virtualization, and containerization technology. So when we think about the cloud virtualization and containers and what was the driver or motive to go for the cloud, the motive for going to the cloud was to reduce the resources required or reduce the cost. In other words, when we rely on the cloud, we reduce the capital expenditures and capital investment, in other words. And what do we mean by capital investment? That in order to build a system, we need to purchase or release a location to be our data center. We need to build it properly, invest in building a proper REST floor, invest in power redundancy, and then purchase racks. And then inside these racks, we purchase servers, we create network infrastructure, and all of this could be considered as a capital investment. And after building our data center, will be moved to paying for the bills, utility, electricity, and technician wages, and all of this stuff. And that is considered as operational investment or operational cost. So we have capital cost or capital investment, which we pay at the beginning to acquire a certain design or a certain technology. And then we should, in order to maintain this technology or this design working, we need to pay for operational cost along the way. So cloud computing helped the organization to solve this issue by allowing them to have their service based on a lot of models. One of these models, for example, is pay as you go. So you do not need to plan earlier and have a data center of yourself, but you can simply lease a server that is accessible over internet. And you can link this server with your organization over the IPsec tunnel. So from user perspective inside your organization, this web server or this server will be similar to a server that inside your same network. But the difference here is that this server is hosted on other body or on some or at somebody else data center. Can you get it? So how cloud computing emerged and how it became so easy for cloud service provider to host millions of servers for different customers and isolating all of them. If cloud provider is using something as servers like this, and for each server he install or she install a Windows or Linux, and then it place it in a separate VLAN for customer A, and beside this one he create a new server for customer B and insert it in a different VLAN, and then this server will be for customer A, and then the second one will be for customer C. So he will need to consider that A and A should be in same network, and B should be in a separate network, and C should be in a separate network. If cloud service provider works in this way or use physical server for each customer, okay, in this case, for each customer we will need, or for each server we will need a completely dedicated hardware such as this one. So if the cloud provider hosts like 10 million servers or 10 million machine for different customer, yeah. So repeat it again. So if the cloud provider use a specific server for each customer, or whenever I contact my cloud provider, such as Microsoft Azure, Amazon AWS, or Google Cloud, all of these vendors and Oracle Cloud Infrastructure, all of these vendors are cloud providers or cloud service provider. Okay, fine. So in order to make a server for a customer or give you a server, the cloud provider will need to purchase a dedicated hardware server, and he will install on this hardware server, he will install operating system, and then he will give you the IP address of this server and will tell you that take the IP address and start to configure whatever you want. Does it work this way, or does this seem logic? It is the logic, by the way, right? So in case I ask it from my cloud provider to add to me or to give me additional server, so he will lease to me the server beside this one. So both of these servers will be for my organization. How to make these two servers can communicate with each other? The cloud provider will place them or both of them inside the VLAN. Yeah. So as a result, these two servers can reach each other. And then another customer will go to the same cloud provider and will ask for two additional servers, customer other than me. So the cloud provider will dedicate these two machines to the other client, correct? And then will place both of them in a different VLAN. This is only reachable from my organization, and this one could be only reachable from other client or other organization network. The problem here is that in order to give a server to each client, the cloud provider will need to lease or purchase millions of servers. Fine. So this could be an issue. And this how the physical server looks like. It is hardware, operating system, and then we install application. So it is hardware such as this one, Windows system or Linux, and on top of it, I make a website. Fine. So do we remember this application? I'm opening it right now. What this application is? That's right. And in reality, the invention of such application was not for giving me opportunity to test on my machine. But in fact, this is a technology that has been in the market since 2009 or 2010. And it allowed the evolving of cloud service providers. It is called virtualization. And virtualization means that on your device, you have a CPU, you have a memory, you have network card, and you have a disk. Not all of these resources will be fully utilized all the time. So you maybe have your CPU working as 10%, 20% normally, and in some few times across the week, maybe you are doing a kind of intensive processing, the utilization should reach 90%, but this is not normal. Normally, you utilize like 10 to 20% from these resources. So companies such as VMware, which created, by the way, this application, created a new operating system called ESXi. This operating system is called Hypervisor. And the Hypervisor is a kind of operating system that do a kind of resource distribution, or take this physical CPU and by somehow it converts the physical CPU to a logical CPU. So I can, using ESXi, create new virtual machine, such as this one. I can tell the system to give this user machine this information, or I can tell him that I will install system later. And then I can choose which system I need to install, how much size of disk that I need to grant for this machine. So this 20 gigabyte will be from my storage, from my hard drive of my machine. But the hypervisor will make what? Will make this space of storage on my hard drive looks like a virtual disk that is separate from the system itself. Make sense? And then I can choose to customize hardware, and my device have like 32 gigabytes of memory, so I can select to grant this virtual machine 4 gigabyte, 8, 16, or even 128 gigabytes according to my needs. My device have a one CPU and a lot of cores, so I can decide which number of cores that I need to dedicate to this virtual machine. And by clicking OK, I should have and click finish. When I power on this machine, I now have a new machine, or I have a separate machine that I can after then mount an ISO image to it and start in installing operating system. But when this machine opened, it will found no OS. So it will act like a machine with no operating system. So virtualization allowed me by using only single server, and instead of installing a single OS, I need also only to install an operating system called the hypervisor. And the hypervisor will start in virtualizing the actual hardware component to logical components, which I can assign to multiple virtual machines. So at the past, one server or one physical server could be able to offer a single service. But now, one server with 32 gigabytes of RAMs can hold up to 10 servers. Instead of having a 10 servers that are physically connected and spanned on like 2 or 3 racks and they care about power resources and they require the air conditioning to make the temperature good and allow all of these servers to work in a proper way, I will need only one blade or one chassis server such as this one. And on each one of these servers, I can place like 10 memories or 10 servers. Looks good? Is everything clear? Okay, so how service provider can, instead of connecting cables to this machine, how he can put this machine in company X and this machine in company A. He will simply select the properties of each machine and it will select what is the network that I need to join this machine to. So assuming that I have on my machine network adapter, I can select any one of these adapters. And for the same company, I should select the same adapter name. So if two machines share the same network name adapter, then they will be able to reach each others. That's how, for example, I was able from Kali machine to exploit this server, and from this server I was able to open this website, because each one of these machines, if we looked for what is the network settings, we will find it's called VMnet 8, right? And this one as well is VMnet 8. So in case I change it one of these elements, like said that the first machine is VMnet 8 and second machine is VMnet 1, they will not be able to communicate with each other. So virtualization is very interesting technology because it saved the cost, it saved the resources, it saved the required storage or space, and also the provisioning or creation of virtual machine does not take time at all. You can have a kind of orchestration in cloud service provider network. So you will gain access to a portal, and in this portal you will just request a new virtual machine to be provisioned for your usage. So you will just click, you will wait few seconds, and then you will get an IP address and tell you that take the machine that you requested. You will need no more to connect a desktop or connect a monitor and connect a keyboard to the server and then bring the ISO image and start to installing it. All of this from the past right now. Try to read and understand more about virtualization. It is very interesting, but what I give you is like an overview or quick overview about it, how it looks like. Okay. So virtualization, as we mentioned, was the core concept that based on it, the cloud providers started to purchase locations, data centers where huge servers with high computation resources. And on these servers, they started to create virtual machines, and then they started to sell these virtual machines to different customers. Okay. So cloud computing has many types, many models. We have what is called the public cloud, and public cloud is something such as Zoom. It is a service hosted on the cloud, and remember, cloud is just someone else's data center. So it is a cloud because we can, it is the name, marketing name, but at the end, it is someone else's data center that you as a customer allowed to access service hosted on other body data center. Google Drive is a cloud service. Okay, Dropbox is a cloud service. Zoom is a cloud service. Teams is a cloud service. But as you can mention, Zoom and Google Gmail and Dropbox are services that are accessible by anyone. So they are categorized as public cloud because they are offered to public. But in some situations, you may have another kind of service, such as you go to a data center in your city, and this data center or this company just offer you the location. They have fire suppression system, adequate access control, good physical security. They are professional in how to secure data center or build a data center that are good in terms of power, in terms of air condition, and in terms of physical security. And they offer you a rack as well and tell you that just bring your servers and place or host it in our data center. Fine. This could be an example for a private cloud. So it is your servers, your own hardware, but it is stored in someone else's data center. The concept of private cloud, however, is maybe more complicated. Like, we have a headquarter, and in this headquarter, we have our data centers. And in any branch, all services are not in this branch or in this location or in this remote location. In order to access service, they need to communicate with the headquarter, right? From this concept and from the logic of these branches, they are using a private cloud because they are accessing their services which is at remote location but over the internet. So that could also be a remote cloud or private cloud. And for all organizations, we are using these two types of cloud. We use Zoom in our business, or we use OneDrive. So this is a public cloud service. Also, we could use a kind of private cloud. So that's what makes the concept known as hybrid cloud. So all organizations right now are using a hybrid cloud, which means we use both public cloud features and services and private cloud services at the same time. So in cloud computing, we have many models. When you were hosting services in your location, you cared about or you were caring about servers, storage, networking, virtualization, OS, middleware, runtime, data, application. So in your on-premise design, you care about everything, which is in the dark blue. But when you move to the cloud and choose to use the infrastructure as a service, the provider will give you the virtual machine. And then you will take this virtual machine and you will set up your own operating system. And then you will start to build your application. So you don't need to care about network, storage, resources. All what you need to care about is the operating system, like patching, like installation, hardening, and all of this stuff. Okay? But in platform as a service, you need to build a website. So the provider can make you or give you Apache server. Do we remember Apache? So Apache is similar to the runtime, which can be used to install a website on top of it or upload website to it. So in platform as a service, you as a customer, you will not care about hardening the system or making security configuration or patching. You will not care about making data or updating the Apache. All of this would be service provider responsibility. In the last type of cloud, which is called the software as a service, you as a customer are not responsible for anything. So the cloud provider will give you like a service such as HR system that are available on the internet, such as Salesforce, Oracle, something like this. And all what you have, you don't need to care about anything. Just you need to upload your data, start dealing with it. But at the background, provider is updating the services. He is doing backup for data, and he can restore the data when it got lost. We have actually many service providers and many cloud-based services, such as Google, AWS, Azure, or Microsoft Azure, or Azure. I really don't know what is the perfect pronunciation for it. Some people called it Azure. I don't know itself. So could you help me? What do we? Is it Azure, 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 Azure? Yeah. Okay. So Zoom is also a kind of, let's say, a cloud service. We have another interesting concept that is considered the next generation of virtualization, which is called the containerization. And in containerization, instead of do a license for Windows machine to install website on top of it, and do another license for Windows machine to install the backend on top of it, and do another license to Windows machine and install database on top of it. Remember, each one of these functions should run on a separate server for security reasons, maybe for application requirements, because maybe the system requirements here is different than the system here is different than here, right? But in containerization concept, which I must admit it is a new somehow to me because I didn't find enough time to read more about it. Okay, although it was in the market for like 3 or 4 years right now, but it is still a new topic and a new challenge. And for everybody who can understand more about it, he may be very professional, or in other words, we don't have a lot of capabilities that understand the containerization in a good way. So it is like a potential new domain that may require calibers and may require people who can understand it. In containerization technology, we may have a single operating system. So you may license a single Windows machine. But on this single Windows machine, you can create virtual isolation inside Windows itself, which is called pods. And each pod have a kind of library and binaries that are isolated from the second one and isolated from third one. And on the same operating system, I can control which can communicate to who using this container engine. So how containerization can be benefitable for the organization? Instead of licensing 3 Windows systems or 3 Red Hat systems to make your application work, which would cost you money, you may license a single system, and using container technology, you can build 3 virtual elements on top of these systems that are totally separated from each other. The containerization, however, has more advanced concepts than this one. I'm just giving you like an overview about it. Containerization can allow you to run an operating system application that would support Windows 2003 on the same server that has an application has operating system or need Windows system to 2020. How it comes? Because for every application, I can create its own partition with all required system dependencies, or DLLs. And these DLLs are not linked to each other by any means. In our Windows system, we have a single system location, which is system 32 or the C drive, right? And any application will be installed on our operating system will share the same binaries or will share the same libraries. But the containerization can help me to segregate these libraries. So I could have on the same system libraries related to Windows 2003, and it should be assigned only to this particular application. I could have libraries related to Linux, and it is relevant only to this application. So we have many solutions that do a kind of containerization, such as Docker, and I believe Kubernetes is a way to manage the container. Okay, and OpenShift is a Red Hat version for how to implement the container technology. So container technology as well as virtualization, as well as cloud, all of these technologies, as they are good and great, of course, but they also bring challenges from security perspective. Do we remember how firewalls could look like? Hardware, right? So at the past, when we were trying to create multiple VLANs in our network, we would create something like this. We would create a switch, and on this switch, we would attach all of our servers, and we dedicate these servers in a VLAN, and these servers are in a different VLAN, and then we can create two interfaces to connect both of them to the firewall, correct? And in case this section need to communicate this section, it should go this way over physical network. But how to implement such thing in the virtualization? This is somehow need some thinking about this part. In fact, it is easy, by the way, from a network guy perspective, but it could have a single issue, which is at the end, I could take an interface from the server, connect it to a switch, and then connect this switch to the firewall normally. But this link is virtualized or segregated to two virtual links or two virtual passes. One for first VLAN and second for the second VLAN. Fine? And then they will go this way. So the traffic from this machine will go this way on the link related to this VLAN, which is a virtual link inside the same cable. It can be done by concept called the trunking. And then we will come back from the different paths. But the problem is we have a single network interface card that could be 1 gigabit or 10 gigabit. So this is kind of bottleneck between these two servers. And why should I leave my server and go to the top of the network and then come back down to the server? Can you understand this? Or not? Okay. To make it clear, we have an issue in virtualization, which it will make us to think different about networking. In regular network, we understood that devices can be connected to a switch, right? What about when I tell you that there is a single server and on this server we have two virtual machines? How they can communicate with each other on the same server? We will have what is called the virtual switch. So logically, on this server, we will have virtual switch that make all virtual machines created on these servers talk to each other. It is logical. There is no need for cables. An example for this virtual switch, when I was assigning each VLAN to a network name. Okay? So what if there is one device in VLAN number 1 and this also in VLAN number 1 and this is in VLAN number 2 and this one in VLAN number 2? Are they in the same network in this case? So which device is needed to make devices from different VLANs to communicate with each other? Router, layer 3. Fine? So the router is reachable over the network. So the server has a network interface card, physical, that is connected to a switch and it is connected to the router. So in order to make device 1 or VLAN 1 to reach VLAN 2, what should be the traffic path? And then? That's right. And why we may need to do something like this, although we are on the same server, because we don't have a virtual router here. So that's why security vendors or routers vendors create a virtual router. And by the time, we also found that there is a virtual firewall. And the network that was understandable from the concept of physical network that we can touch by our hand can now be on a server. So everything is inside this server: router, switches, firewalls. So physically it is a single server, but is logically it looks like this. We have virtual machines, right? We have switching layer, which is virtual. We have router layer, which is virtual as well, and all of it is inside the same server. So all the traffic is going to the same machine or inside the same server. But in case somebody from outside these servers need to communicate with these servers, then it should take this cable and reach to the switch. Complicated, yeah? Yeah, of course, this is like an introduction, but you need to be aware about what is happening in the other area. There is kind of evolving in how servers will looks like. There is kind of new technologies that are here. We now have, by the way, the concept of virtualization is called, as I believe, software-defined data center. Software-defined data center. Okay? So we have another concept right now called software-defined network. Okay, so instead of physical network and physical servers, we moved to virtual. And instead of physical network, we moved to virtual network as well. At the end, we will still need, in some area, physical network and physical server. But virtualization and containerization is sort of new challenges that we need to be aware of. And this is, by the way, another opportunity or another domain that you might be interested to read and understand more about it. Because containerization will have security challenges as well as virtualization, as well as the cloud. There is a security certifications related to cloud service only, such as certified cloud security professional, such as certified cloud security knowledge. So everything comes with the challenges, and we as security people need to be aware about these challenges. As you can see, I'm not professional in containerization, but in some stage in my life, I worked with virtual machines a lot. So the concept of containerization could be understandable if I invested some effort or some time to learn more about it. Okay? So that concludes the part of virtualization, cloud, and containerization, and that was only like a quick overview.